Hello. All right. Good morning, everybody, and thank you for coming. The world is supposed to end today, according to some numerologists. So we have some sort of a mystical image right here, just CHIRON. We hope you enjoy the presentation. What we want to do today is introduce you to this open source project that our employer JASK has encouraged us to share with the community, and hopefully this will be the beginning of having true machine learning at home. Basically, what we want to do is take it away from the tech elites, take it away from the Silicon Valley circle. We're going to put it on GitHub, and it will be downloadable. There is some code already in there. It's not ready yet, I can tell you that. But today, you're going to see all the principles, the architecture, the algorithms we're going to use. And then once we release it, it will be yours. You can develop on it, add to it, whatever you want. So let's begin. My name is Rod Soto. And I'm here with Joe Zadeh, my partner in crime. We'll be working in, we've been working in machine learning AI for about 4 years now. We started a startup called Caspita almost 4 years ago, which was based in Palo Alto, California. Back then, we were looking at what is called today UBA, which is User Behavior Analytics. It's mostly what some people will call SIM 2.0. And we were successful exiting the startup. We're acquired by Splunk, and that product today is Splunk UVA. And then from there, I went to JASK, and Joe followed suit. And what we try to do at JASK is what you call a future SOC. A future SOC is basically you replace SOC 1. I used to work at a company called Akamai Technologies, which has one of the biggest SOCs in the world. And one of the things we noticed, or I noticed back then, is that SOC 1 is a position with a high turnover. These are kids that just came out of college, and they're just reading scripts, and most of the time they will send you false positives or declare incidents where there were none. So what we're doing is try to learn what is needed for this type of level at SOC 1 to operate efficiently, apply machine learning, and then replace it. Replace it not in the sense to get rid of humans. Replace it in the sense to empower SOC 2, which is the next level. And if you actually been following what's going on with machine learning and AI, it will push all of us to go to the next level, because it looks like many basic levels in many industries are going to disappear, and SOC 1 will probably be one of them. But I will talk to you more about it in some other time. Today, I'm bringing CHIRON, and we'll get to it in just a second. Joseph is Director of Data Science at JASK, and like I said before, we're working together for almost 4 years. He used to work at Pivotal, Kaiser Permanente. He was with me at Splunk as well, and he co-founded Hack the Valley Percent 27, which is a hackerspace in Silicon Valley. We meet once a month around Mountain View. So let's follow. So what we try to do basically with CHIRON was is try to apply some of the principles of the Lambda defense, which we'll be explaining here. Joe will be going very detailed to it and bring it home. Right now, as you can see there are some tools that some power users, and I would say power users because a common user really has no vision into what's going on. They go in, they open a little booklet. The booklet tells them, click here, click here, click here, and that's it. You're on your own. They have no idea. if the webcam is being accessed from Russia, if their baby's being monitored from who knows where are the kids connecting to, are they being, is there a backdoor? Is their work laptop compromised? So there is no way right now, unless you're a power user and you combine your knowledge with many different type of sources and disparate products to find out that something's going on. So our motivation comes from obviously different sources of products that are being developed, either open source / commercial. We already did our first step by creating Acteon, and if you see it right there on the top left, Acteon is an open source tool that we presented at Black Hat Arsenal, and basically it has right now 2 detections. One of them is for ransomware, and 2 for delivery of phishing delivery. You can actually find this code in the presentations on the GitHub we're going to show you. So, as I was saying, there are a series of challenges in the home networking defense. Most of all, the common user is oblivious to all this. They had no way to see this. And now we have the Internet of Things, where we have toasters, refrigerators, thermostats, cameras, wearables, AI, routers, printers, you name it. Most of these devices, most of you may know, they become vulnerable at one point. They're not upgradable in some of them, and they mostly become zombies of very large botnets feeding the crime ecosystem. CPEs, of course, are prime target. CPEs is customer premise equipment, and that's what telcos refer to as your router, so your home router. Right. If you want to have a good idea of how bad this is, I'll suggest you come down the first floor and play the IoT CTF, and you have a good view of it. Common users, they had no idea or knowledge of what to do in this home infrastructure. So now we have a home infrastructure. I'm not sure if you guys ever play with Google, the Google Wi-Fi. It's actually pretty cool. It allows you to see all your devices. It prioritizes some devices over others. There's also some, I believe it's Netgear Nighthawk, which is a gaming router, excellent router. And I actually, what I ended up doing in my home is I ended up building 3 Wi-Fi networks, one for IoTs, one for my lab, and one for what I don't want you to see. So these devices by themselves are very fragile. Even if some of them, if you're trying to scan them, you're going to have to reboot them. Sometimes, let's say if you have, I don't know, you probably have, for example, Fire Sticks. I'm telling you, put the Fire Stick, I have 3 of them. Put the 3 Fire Sticks and start talking to Google Home, and watch a couple of movies. I promise you, it will collapse. They'll slow down. You have to reboot them. So this is just an example of how fragile these devices are. And of course, the privacy risk, right? So we have external IPs accessing webcams, child monitors, even people unlocking doors remotely. We now have, if you think about it, we now have a mesh of infrastructure at the micro level at home. So we have Zigbees, we have Bluetooths, we have Wi-Fi, you name it. So there is no vision into any of this. We wanted to somehow apply some of the machine learning, analytics, security focus that we've been doing for years into home. So these are some examples, of course, of things that usually happen: Wi-Fi poachers, P2P piracy, someone using your network as a VPN. You have targeted attacks against your organization via your home network, targeted attacks against personal property, identity, finance, insurance, people sending spam, 425, 110, 143, 993, 465, somebody using Tor from home. And then this is what we wanted. Right? We wanted to get this available to everybody, not only the Silicon Valley people, not only the Stalkerverse or the mosques, We want to put this out, and I believe this is a great community of people incredibly intelligent. And even if you are not yet familiar, I'm sure you can read, you can study, and you can get up to it. And there's no longer will think some sort of a black magic box that's happening. You will have you can apply it at home, and it will help you for your own job. When some of these vendors are hyping stuff, you hear, you understand what they're trying to tell you, and make the right questions. So it's our effort to bring basic analytics to the masses. This technology can help everyone, not just large enterprises. We try to make it simple and easy to use. That's going to take some time. Machine learning can help everyone at home, and in the small business. I'm sure this will be translated into small business at one point. Seeing is believing. This basic statistics will provide an overall yet sufficient picture to understand what's going on with your home network. Like I said, going back to seeing is believing. If you don't see anything, you had no idea who's connecting to what, well, certain basic statistics, this will give you at least a little bit of an insight of what's going on in your home network. So here, machine learning or any single point solution is not good for defending against advanced actors. Yeah, and that I will go over in in a later graph of what exactly we believe is the best place for machine learning at this point. So using machine learning will allow us to put together simple statistics. One of the things that we focused was data models that will get assets, services, protocol, users, and traffic. This will allow us to go beyond the static signature, where you just see, oh, okay, it's on or off. And a lot of times these things are false positives. We try to steer away from anything signature based. So it's behavioral, and it's based on contextual elements that we'll call micro behaviors. I will go over what micro behaviors are in a second. So obviously we're aiming to augment what you can see and apply a solution with output like broad snort alerts or eventually type block changes. And we apply some of the IDS best practices, analytic algorithms. Joe will get in detail on what algorithms we're using. And we create a scenario where threats are based on multi-contextual indicators. So here's some of the use cases that we're aiming to address with CHIRON. Malicious file downloads, fingerprint users, services, and protocols, high-risk users, assets, domains, data usage, north-south traffic, relationships between assets, social media usage, and all application traffic and services. We didn't want to overreach or overextend, even though we're using some of the libraries present in Hadoop. CHIRON is not scalable. We designed it to be home, right? 10 to 20 devices, simple. And eventually what we want is click, let it do its thing, and then look at the statistic, and then you got a picture. If you want to go beyond that, then, you know, you gotta, if you want to scale, you gotta go back to Hadoop and a different type of architecture. So as I was saying, you don't need a Hadoop cluster. There are several open source tools that you can use to have a decent proof of concept or network analytics plus machine learning. No snake oil. This is open source. It's going to be out there for you to use it, to critique it, to add to it. No need for a network tab. We try to address that. You can do an end-to-end, or you can do like a network tab. That will be for more of a power user. But we wanted this to be as simple as possible. We actually were at first we were trying to do a binary that would run on Security Onion, but then we realized once you add EOK, with all the library dependencies, it was a little difficult to put it at Security Onion. We're using passive detection tools such as POF. We're using Nmap. And like I said before, you can use a network tab to pipe the output. Yeah, the Security Onion is still there. We need to figure out how to pack it to put it in. And eventually the idea is to do fire and forget. No need to code, no need to do anything else. Very quick onto this, questions that this may answer. Where are devices connecting? Where are all my users connecting? Is there any suspicious north-south traffic? Dynamic asset discovery. This is very important. Do you really know what's running on home network? Is there a neighbor connecting? Is there somebody? I've seen cases where people have gotten violations from their ISPs because somebody was basically pirating movies. And in some other places, I've seen people put in spam servers. If you live in places where there's a high density of Wi-Fi, like an apartment complex, you're bound to be affected by this type of things. We talked about the targeting and phishing employees at their homes. This is like a use case. And IoTs are big leakers of private info, unpatched, vulnerable, and they present a significant risk. So 3 basic tasks that we want to achieve: perform basic discovery and analytics of home network assets, IoTs, workstation, laptops, servers, and routers, fingerprint users, services, and protocols, and then apply analytics to users and devices. Average session length, for example, traffic and sites that were visited. The tool, here's the code. Where's going to be the ISO? That's the VM. The requirements, it can be deployed in a VM that we created. It's going for home networking, 5 to 10 users. I'll say you can stretch it maybe to 15, 20. I mean, if you had, let's say 4 or 5 TVs and you had Fire Sticks and then you had Chromecast, it will scale to that. And that's what we had in mind when we designed it. And for now, it has a 30-day log retention standard. We use EOK for visualization and simple interactive analysis. So the core principles that we base this on: the Lambda defense. The Lambda defense is use of big data technologies for distributed processing and analytics. Microbehaviors. Microbehaviors are basic units within an exploit chain or the threat. And then we have a deployment model. Deployment model target a specific home use demographic for ease of use detection of change point behaviors linked to threats. The Lambda defense at home. Let me just do a little notes about it. Large organizations are currently attending to scale intrusion detection by using big data distributed processing technologies, mainly Hadoop. CHIRON does not depend on Hadoop infrastructure, even though it uses some libraries that are part of the ecosystem. CHIRON is not meant to scale to thousands of users. However, it's based on the same analytic principles and some of its machine learning frameworks. By identifying, analyzing, and providing key analytics for home network security, CHIRON gives home defense insight that is simply not available at this point without technical expertise and hardware. Okay, so what are microbehaviors? Microbehaviors are basic units present within a threat or an exploit kill chain. In order to define the microbehaviors, we had to label data. We had to give it a value within a context of a threat or an exploit kill chain. So here's an example of a microbehaviors that are present in a ransomware attack. So we have payload delivery, focused on traffic to malicious sites and related indicators. We include things such as URI entropy, redirects, domain generated by algorithms or DGAs, types and sequences of MIME. So for example, you have a text, then you get a flush, then you get a binary, then you get a bunch of GET requests. That right there looks like an exploit kit, right? Even though at times can be confused maybe with a CDN or an API, you had to train the model. And I can tell you this as experience on some of the models that we developed during the years, APIs and CDNs, specifically CDNs. Me coming from a CDN, at one point, I can tell you they don't want to release their IPs because their competitors will block them. Remember, when you go through them, you pay. So usually they don't make them available. And also they use something very similar to a DGA in order to serve the URIs when they're distributing content. So this becomes a challenge. We already talked about that. We have callbacks, get, post requests, DNS queries, URI strings, frequency of callbacks, and periodicity of connections. We also have the use of cover channel indicators such as non-HTTP traffic, HTTPS, or non-DNS traffic present during such communications. A little bit of an entropy to a URI or URL. We have things such as number of dots, special characters, the use of URL crazy. You can also apply whois, which is probably register with bad reputation, geolocation, or bulletproof hosting, basically IP rep. And then we also have URL shorteners, spelling errors, presence of iframes. So when you put all this together within a context of exploitation and entity behavior, you put those two things together, we can develop a method for detection, then train the models, and then test detection. Would you like to chime into this? Or here's an example of a code. This is Scala code, and basically this is a little piece of a sample of the code and how we actually, if you can see on the left, I'm not sure if you can see it, but this is how we label micro behaviors. And this is part of Actaeon, which is, by the way, Actaeon was integrated into CHIRON. Actaeon and CHIRON will continue being developed, but whatever we develop for Actaeon is going to be implemented into CHIRON. So we're trying to scale OPSEC to the home environment. There are some tools. Here's an interesting presentation of DEFCON 17, asymmetric defense, how to fight off the NSA red team with 5 people or less. So this includes some of the tools that we mentioned before, plus it's bootstrapped to FreeBSD, using things such as Monowall, IPCOP, Untangle, pfSense. Many of you probably have pfSense already at home. I looked at it as well. But the goal of this is to make this type of techniques easier to adopt for non-power users. So, okay, so here's how CHIRON learned, and I'm gonna have Joe go from here.
All right, thanks, Rod. Hey, my name's Joe. I'm sort of one of the data scientists on that's been working with Rod basically on just a lot of different open source projects over the years, where we really try to, like, part of the goal in any of these projects we're doing with the community is just to, like, demystify some of the buzzwords. Particularly machine learning is kind of thrown around a lot, and in the context of, like, adversarial modeling, kind of just any type of software automation where we really have to determine kind of when an attacker has sort of leveraged some type of new technique, and how we sort of adapt to this technique. This is sort of like a corner case for kind of software engineering in general, and typically like when we see these problems solved at scale for like a large, like Fortune 10s will kind of go through sort of this sort of thought process we'll talk about in a second, and really design these solutions. Like this is sort of an algorithm that we took from, like, an implementation of a kind of a really large scale solution that is meant to protect hundreds of thousand users at the same time. And one of the things we noticed just working on a lot of these really cool projects like Amazon, Facebook, Google, they're all kind of stand up these huge infrastructures for kind of learning attack behaviors, doing a lot of automation. Like, went to this Facebook talk recently where they said they only have one person on help desk because they, like, reverse engineer TCP/IP. They have all their kind of machines in their data center doing so much automation and adaptation in code that these results are really cool, but they don't really, like, scale down. They're not like helping our parents and some of these users who are less kind of fortunate to know sort of the vernacular here. But kind of what we're kind of focused on is just sort of isolating the sub problems here, and just kind of getting good at a couple of them. The key kind of thing to really learn, it's nothing fancy, like, is just sort of like when are there change points in the behavior of services on our home network, on our LAN? That's kind of one of the key intuitions. the other key intuition that we kind of get for free. So this is like our old Black Hat project that we were just presenting at the Arsenal talks mainly. And this is just kind of a sort of standalone module we forked into this that's basically takes PCAPs and identifies with sort of what's called a random forest, or just a sort of a generic commodity machine learning classifier. And this classifier will tell us if the PCAP has an exploit chain based on samples we trained and labeled. And kind of from a machine learning standpoint, like what enterprises are heavily invested in is kind of having these really nice data sets that are labeled. And so that's mainly part of the effort here, is to open source all the data we're training models on, and just kind of engage the community like this. There's, we've been kind of building these open source tools for the last few years, and it's, we have like a Slack channel. It's all kind of non-commercial. This is all just part of the Hack Miami space Rod runs, and kind of think of this as just a call to get involved and learn about some cool things at the end of the day. So there's kind of like to start, and hopefully we can kind of add coverage over time, depending on involvement. But really, we're sort of targeting a class of adversary that we want to make, that we can get some coverage for with this type of solution. And we want to sort of kind of limit the scope of this problem in that sense. So I think probably where we're going to stop with some of these techniques is maybe at the ransomware, crimeware level. I would say, like, if we were worried about like an advanced threat actor targeting our home system, it's never like a good solution to just throw like software at it. Like, advanced actors are trained in kind of like sort of nation state level exploitation. You're going to have a sort of a kind of a defensive paradigm and human tradecraft that's going to kind of counter that. And so I think what we see in sort of mature kind of security models in the bigger environments is sort of a proper model of the adversary. And so I think that's kind of where we usually will sort of break this down kind of in terms of, like, we do this a lot for like the enterprise modeling problems, where we kind of are giving a particular use case, like let's say it's like command and control. And kind of what we try to like this is kind of like my sort of almost like a gauge of security maturity when I'm talking to a customer particularly, is like how sort of kind of premeditated is their idea of like an adversary class overlaid on top of like what they're defending. And so kind of part of like one axis is sort of our threat surface, like what is all the things we got to worry about, and the other axis is like what are the threat actors that are targeting that threat surface. And then you can kind of like, and usually there's like lots of subproblems on the threat surface. Like in a big enterprise, we're worrying about web shells, we're worrying about like lateral movement with pass the hash, pass the ticket. And so typically what we try to do is sort of sprinkle some different, like, kind of at the different layers of the adversary model, just different techniques of different detection paradigms. And I know Rod sort of mentioned something about rules. I think one of the things that's really important to note here is that we don't want to throw anything away that we're already good at. And so usually what we'll kind of apply from a point solution perspective is at the first layer, like the script kiddies, or people are kind of just in a more opportunistic, kind of like low sophistication of attack. We can leverage kind of basic data, like change point detection on, did we just discover some new services being, fingerprinted in sort of our land space, or were there any hits from Snort, Bro, or Circata, and just kind of like graph baselines of traffic, which we'll kind of visualize in a second. I think what we kind of get up to a little bit more, like we're talking about sort of a Zeus, or maybe a little bit more of a targeted attack that's kind of based on some of these classic kind of crimeware outbreaks. One of the things we built into this particular solution is this idea we spent a lot of time thinking about that basically leverages kind of the passive stance of POF, passive stance from this just the network tap itself, and building some data around the context of all the devices running in our network, and what is sort of their typical application profiles. This kind of will let us really kind of target when our network routers start behaving out of band. And basically, we've used the same technique to detect web shells in the enterprise. So I think that's one of the key insights here is sort of these are kind of like, I probably could have done a little bit better with this slide. I mean, not all these things are kind of leveraging machine learning. I think we have sort of kind of machine learning here, which is sort of the Action piece I'll talk about in a second. And then a lot of other just kind of basic statistics and more like architecturing the right data flows. And I think like when we usually kind of talk to like enterprises to try to educate them about like where all these kind of buzzwords fit like in this modern language of artificial intelligence, I usually try to show like a customer that like maybe if we're talking about where machine learning fits into like a modern defensive solution, it's usually like from here down. Like if we got to worry about like an advanced like threat actor, we need to tool up and we need to have training and kind of the proper sort of layers of defense in depth, among other things. And so kind of just to go back to like, how do we do sort of this little piece of the web show detection? I'll show you the kind of the visualization. We didn't really have Kibana in the place we wanted to kind of show you the outputs of the screenshots itself, so we're kind of doing some offline graphing just with like Python libraries and stuff like that. But the key insight here is like to have enough, like basically our data flows and the things we're collecting with our sort of the CHIRON IDS is sort of a collection of log samples that we're sort of deriving this pictures. That's what we mean by sort of dynamic asset discovery. So we want to see like, okay, well, what is my cell phone? Like, what does this thing normally do? And how often does my cell phone talk to like, my PC? Or how often does a cell phone talk to another cell phone? Or, just kind of building this asset graph. And once we sort of can discover this, so this is really kind of ugly at this point, but basically what we do is we sort of have like a job, like sort of a collection job that runs on a 4-hour basis, and basically it's just kind of color coding our services in a way that we can then just say, okay, these are all the cell phones, this is what they typically talk to, these are all the IoTs, this is what they typically talk to. And it's at some point we get a little change point if like when we'll have Rod red team some of the IoT networks and try to get them to break into the Philips Hues and stuff like that. And once you see one of these things pop, it's basically like it's very simple to see kind of the statistics change, and what we're kind of trying to output for like end users who aren't consumers of like the power tools is just some visualization. And this is all sort of in flight right now. This is just kind of one of the prototype mock-ups. These are all things that, and anyone who's interested in working on this is sort of where we're basically we're trying to have this done by, we kind of pushed our release date to October 1st after we're kind of still some work to be done here. Mainly what we've been kind of doing from an architecture standpoint is just building out, like, so this is sort of what lives on the ISO, like if you download it, is this sort of like workflow that's kind of mapped to a couple of like cron jobs and Unix services. And so kind of if we get into like the meat of CHIRON, it's just sort of this set of steps where we're kind of kicking off like basically these tools in sort of in kind of a periodic job, and either Nmap and POF are kind of hacked together a little bit. This is sort of Bros just kind of running in a standard inline or network tap mode, and Nmap and POF are kind of running as sort of basically like little services that are constantly scanning our subnets or some user-defined configuration of where we want these things to look. And this thing is kind of, POF's just sort of sitting passive and giving us some additional data. And then what we're kind of leveraging is just sort of like a normalization framework that this is sort of how a SEM works. Basically, it takes a bunch of different logs, kind of gives you like a nice sort of semantic schema that then we can kind of hit some of these data sources with things like Python, scikit-learn, and some of the other kind of analytic libraries that basically take this and just get some data frames out of them, normalize them. And then one of the key things that we're like, there's just like a little kind of active defense thing going on right now, was that like if kind of doing this processing and running this job on like a periodic basis, if we find some change point detection, if we find like a new IP we haven't observed in the last 30 days, we just hit it with Nmap, and then we just try to visualize that. And that's kind of the basic intuition here, is just sort of starting to bake some of these things in, seeing where they're working good, and just sort of experimenting. I mean, and then there's kind of like a lot of detail here. This is mainly like the stuff we've been I mean, this is sort of totally community driven. So like right now it's basically our weekends where we're kind of writing this and just kind of using it, like working through this architecture as a kind of skunkworks project. And so these are just slides I've been using, like kind of to brainstorm with the developers. So things kind of mutate over time, but basically this is kind of the details of our, we have sort of an analytics step here, and we kind of just derive some statistics, and it lets us sort of do the thing like, did we have a new service? Let's hit it with Nmap. And then one other thing we get for free, this is kind of where I'll go, and this is sort of where some of the cool kind of machine learning comes in, and this is just meant, originally when we kind of published this tool, the Axion, this is just sort of meant to be a teaching tool, more about kind of these general broad topics of how do we label data, what's a good use case for machine learning and security. And so we kind of forked it. This was originally a standalone tool that was meant to do some other automation. Originally, when this tool kind of hooks into PCAPs or bro data frames, and what it's going to do is it's going to tell you if it detects an exploit or not in the traffic. Originally, it was designed to take action in Active Directory. So the original Axion code actually ties into it generates a group policy object, and it'll push policies to your domain as a kind of based on IOCs it sees from kind of this sort of workflow here. And so we kind of disabled that functionality essentially. There's no sort of Active Directory integration with this use case anymore. I think kind of like, I mean, so I've been going to like DEF CON, the first DEF CON I attended was DEF CON 9 in Alexis Park, and there was, I think it was like right around then, I was trying to find the reference, but one of the coolest talks I saw like a long time ago, I mean, this is sort of a different era of security, but these guys were just talking about these old kind of, like old passive, like old espionage tricks, basically. And one of the things they would do was like when they were just talking about generic eavesdropping. I mean, this was sort of like in the late 90s, so I don't think the proliferation of wireless had happened as much. But basically, back then, what they would do is they would take like a Cat5, and they would not terminate. They would only terminate receive, but not transmit. And so you get this really nice sort of passive kind of interface that is really hard to target. You know, I don't think we need to kind of do that in our V1, but we're just sort of thinking about kind of the next ways to sort of roll out a little bit more of a kind of like a honeypot style architecture where we might have like a trap and then a shadow IDS or something. We did all so that was one thing I like working on, kind of just the architecture of kind of making this more lightweight and having at least of a detection footprint as possible. So that was one thing we're kind of scoping in the short term for the next kind of integration. The other thing we really wanted to do, we just didn't get to, and this is kind of one of our other metrics for kind of security maturity in a large organization, is given a network flow, given like a perimeter piece of evidence, like a proxy log or a net flow, how easy is it for the SOC analyst to go from that flow back to a process on an endpoint? Typically, that's pretty challenging in your like mid-range Fortune 500. But what we can kind of do is bootstrap that. Like, so the smart shops like Facebook, Amazon, they're kind of integrating this with sort of like automation tools and really getting that visibility or kind of tying into Carbon Black or some of these endpoint tools to say like, okay, I have all this information about like the use case we heard that was really interesting was like it was sort of a really large financial institution. So what they were doing is they've been compromised by a threat actor who spent the time to reverse the connection to Gmail, and so they're getting C2 over Gmail, and it was going through all their point solutions, all the call alters, because it was whitelisted. And the way they found it was kind of like this OS query principle where they basically crowdsourced the checksum of every version of Internet Explorer in their entire environment. And it turned out that like if you kind of just do basic frequency statistics of the process, the MD5s of the binary associated to Internet Explorer or just any of the browsers, you'd see like 30% of all users had this binary, 15% of all users had this binary, and there was one user who had a binary that had never been seen by any other user, that any other person in the entire environment, that was like doing C2 over Gmail. And so those are kind of like the those are sort of the nice kind of data-driven results that are more about like just kind of finding some of these use cases. And OS Query is a really cool tool for that. I think that's one of the things I really love working on in general. Like it's just a fun kind of project to integrate and learn more about. So yeah, we have sort of a lot of kind of like roadmap ideas and stuff, and just come talk to us afterward if you really kind of just want to get involved. And then just kind of the last sort of little piece of machine learning here is the kind of just to give you a sense of like what we integrated for mainly like a standalone like supervised learning classifier. And so this is kind of an end-to-end classic case of having data that's labeled that we kind of created from our own sort of security tools, both attack data and benign data. And this is basically the piece of Action that's you know, it's more just like a proof of concept at this point, but this is the piece of Action that's really focused on the delivery of an initial exploit, or even when a user clicks on like a phishing link, this is kind of where we're like, you know, we're not throwing rules away, we're just sort of augmenting it. And I would say it's more just a proof of concept. And I think we're just where we are like where all our data comes from, and kind of where the history of this part of the detection comes from is we're just focusing a lot on I mean we were working on like Splunk instances where we just kind of googling for searching for IOCs like gate.php and just kind of classic indicators, and a lot of what we would see that was actually kind of making it through even, you know, pretty advanced point solutions was sort of some of these kind of phishing attacks that were leveraging the exploit kit frameworks and either watering hole, malvertising style watering holes, or just kind of just spamming like mailing lists at enterprises. And kind of if we just sort of walk through the anatomy of these things, like for instance, we saw, if we see sort of like an email phishing campaign, what kind of happens is there's sort of this sequence of behaviors that's really important to sort of like just study if we're trying to build a detection for this. And the sequence is kind of like, in some senses, is captured. Rod already hit on this by the sort of the evolving MIME types in close time range. And so, like, if we kind of think back to the initial user sort of going to a sort of a staging area where the link they clicked on a link from an email. To the next step in the sort of the exploit kit kind of paradigm is it's just looking for a vulnerable service. This is where you will see like a MIME type. Typically, this MIME type will be like text HTML. The next one is going to be kind of like a probe for like a vulnerable version of Flash. You see Silverlight. Just a few sort of the common web applications where you can see potential exploits being delivered. And if one of these versions of Java or Flash is actually vulnerable running on the system, we'll see a payload which is usually a binary octet or something that looks like this. So just pull the data out of here. So basically, kind of what we're seeing here is sort of like a malicious ad kind of that's being served by some sort of benign kind of website like Forbes. And what happens is that redirect will send a user to kind of the actual kind of the exploit kit infrastructure, where sometimes the exploit kits fail is at this step. So if there's not a kind of vulnerable version on the host that's being targeted, you won't see kind of the payload in the next step. But this is sort of one we curated, so we kind of see the full exploit chain. So redirect, Flash exploit, and then the payload being delivered. And for ransomware, so we were kind of when we were sort of originally spending a lot of time looking at these sort of the delivery of ransomware and stuff. What's interesting about kind of ransomware and the changes in sort of the overall like just like common behaviors associated with some of these exploits is that there's oftentimes no command and control when the payload is delivered for ransomware. They just encrypt and then they just wait. You know, they don't have to do anything. But kind of what we used to do before the ransomware days was kind of get really good at detecting the rat and the covert channel that would sort of happen following this chain. But I think if you kind of read, like there's a really cool, it's really like CrowdStrike now. It's called Most Shells, Most Problems. But they're just, you know, it's kind of like the evolution of attack behavior, especially in the advanced actors. Like, like if we don't catch this and there's no command and control, even in sort of the case where it's more of like it's not ransomware or something, but if it's kind of the case where we're seeing these web shells being deployed at the perimeter, and then certain teams are leveraging like in-memory malware to do kind of the next stage in the operation versus sort of these classic tools like Poison Ivy and HTrend, stuff like that. So kind of depending on what follows here, we didn't spend too much time in that. And like we really kind of spent time kind of getting a tight sort of heuristic and combination with the random forest for the intuition here, which is basically, and I think of the like 500 or 600 like exploits we were sort of studying, the longest exploit window was like a minute or a couple minutes. So we sort of have this bound on kind of what is in scope, and that's kind of what defines how we sort of limit what we're kind of like ingesting for this problem. And so this kind of the workflow for that detection is basically we sort of have step one was kind of our standalone code, so kind of the CHIRON version of this. Basically, we're sort of starting at step two, and we're basically kind of building. In machine learning, we call this a feature vector. It's synonymous with sort of sequence of micro behaviors, but basically we sort of have a sliding window. Maybe I'll just skip to this. Yeah, let me just sort of walk through the picture. Yeah, so basically kind of the steps here are kind of like if we plug into sort of where CHIRON kind of is looking at, it's basically taking this piece of the logic and then sort of taking a SQL group by approach, so it's sort of grouping by source. And so for each source, we just look now sliding a window through kind of that source's traffic, and it's just the HTTP traffic. And what we're doing is for each window, we output a sequence of features, statistics about that window. And this is kind of the data structure that's input to our, originally this was like in Spark, so this was called MLlibs, like API for random forest, but now it's a scikit-learn random forest. So it's pretty just vanilla, kind of just like you can kind of just Google Python random forest tutorial and you more or less see like the implementation idea we're using. But we're basically kind of using just a step here for classifying the data we see in these sliding windows, and that's usually what we call in machine learning supervised learning, because this step this algorithm that says okay this thing is either an exploit or benign is based on data we train the algorithm on. So there's some details there. The cool thing about this is it's all this is kind of really well documented. So if any of you guys are interested, kind of just there's sort of a sister repo for this, and all these prezis will be kind of landed. Like we have all the documentation in the repo too, like all our old PDFs and slides and stuff. So I think there's sort of good documentation here. And just kind of to like hit on maybe the last couple minutes, or just sort of like an anecdote on like we use this a lot just to talk about kind of like what's really happening, what's going on under the hood. And I think one of the goals with this, there's a lot of buzzwords around machine learning for security is like, you definitely want to think about it as kind of like just a tool that maybe is good at some of the sub problems we encounter. But there's a brittleness, especially if we're engineers, like engineering this stuff, like engineering learning and engineering software to adapt is super complicated. Like our evolution's given our wetware the ability to adapt to adversaries, and we're sort of good at it, but like it's taken, I think, billions of years for our own kind of internal hardware and wetware to really evolve to a point that we have enough context to adapt to capable adversaries. But anyway, so kind of just one last thing to sort of walk you through in general, just to take away on kind of hopefully like demystifying some of the black box stuff in machine learning. So like really what happens in these algorithms when we take something like random forest, when we take any classifier, any machine learning library, what we're kind of doing in some ways, we're sort of taking a really smart hash of the data. So there's this concept like in like academic literature, it's called VC dimension, but it really means like whenever we learn something, we're really kind of compressing it. And kind of let's sort of like see what that kind of means visually. So what I'm going to kind of do right now is just train sort of the simplest type of machine learning model possible. It's a linear model. You might have done this, like, you can even do this in Excel. You basically are just fitting a line to some sort of data points that we think are predictive. And so in this case, what we're going to do, this is just like it's extracted from R, like this library for just kind of doing real quick statistical modeling. That's free. And what we're doing, so they have a built-in data set about cars. This R library has a function called linear model. And so what we're saying with kind of this model is that the data in my data set, there's a column, miles per gallon. This is sort of the thing we want to predict. Well, we're saying there's a hypothesis here that basically miles per gallon is some sort of has some linear relationship to weight, displacement, and cylinder number. And each row is kind of the statistics for a particular model of car. And so, I mean, this is sort of like a benign example, but I just kind of want to show you like what happens when you actually go through all this engineering, go through all the code. What is that? What is the output of this model? Well, it's a set of coefficients that describe our original data set. So there's actually like a major compression, and this is happening like in CHIRON. This is happening in any application. It's happening in our brain. Like it happens like when we learn things. That's why when I need to react to something after the first time I've learned it, I'm kind of looking at like a hash of the memory. And so this itself is brittle from a software engineering standpoint. So that's one of the takeaways here is that anytime you're doing machine learning, you're actually compressing the data. So what's more like, and especially in Silicon Valley, like data scientists, algorithms are becoming very commoditized. Like what's really important is that underlying data that we're building the models against. And so I don't know. It's more just like something to just a general like piece of knowledge to give you the ability to kind of like talk about machine learning if you're interested in it in sort of a more of an intelligible way, because I'm very skeptical of people that are saying like we're using machine learning for security and stuff when I'm well aware of kind of the brittleness of the engineering applications, and that's why the devil's in the detail. So if people are bringing this topic up, like the first thing I scope is what is the nature of the data you're training on? There's a lot of solutions we see pitched, and what's most important for us is kind of sharing the data and the code that and the underlying ideas. So yeah, so that's kind of like a digression.
You want to do questions?
Yeah, I think maybe. Yeah, we had some other slides like that are kind of more just on the theoretical side of stuff. Like Rod mentioned this thing called the lambda defense. This is from like a machine learning paper that basically is kind of a high level pattern for modeling any kind of adversarial situation that kind of scales to like hundreds of thousands of users. If anyone's interested in any of these kind of things we just touched on, this is another sort of underlying principle that's kind of sort of manifests in a little bit of the architecture and stuff. But just all this stuff is kind of in our GitHub. I'm trying to find the links. Yeah. Yeah. So and then maybe just questions.
Yeah. Go ahead.
So you talked about using windowing in your future lecture. How do you handle do you overlap in windowing?
Yeah, it's kind of hacky right now. Like we could have used like more of like a proper sequential learning model, but what we really do, so we sort of slide a window. We just naive. It's as naive as possible. Basically, it's kind of embarrassingly simple. For each kind of like you fix a window length and then you just slide it one row at a time. If we detect anything interesting in that window, like part of what we're doing as a hack for the features is like if we go to, let me just find this picture real quick. Oops. Did I lose it? Yeah, we sort of had this slide with like our micro behaviors. This is kind of like describes. This is sort of like a configuration file that I was using. And part of these micro behaviors, I don't know if they're going to show up big enough. Yeah, so part of the hack here is kind of like, or just kind of like getting this sort of as a lightweight computation, easily to experiment with, is overlaying as features like the number of times, in that window, how many timestamp differences or deltas of the timestamps in the window are less than a certain number of seconds. And so we overlay a lot of sequential statistics within a window that kind of gives the algorithm some insight to learn those sequential patterns.
Yes, sir.
Assuming this finds a bad behavior, how does it communicate to the family or the home, or how does it express that there's a problem?
Yeah, and so that's kind of the last step where we were sort of I kind of dropped the ball on having screenshots here. So part of what was kind of important about what we want to make this as easy as possible for someone who's not a power user to use is basically kind of showing alarms or reports in Kibana to start. That's one way we kind of started to scope it, is just sort of have this top end list and say, like, for this day, this is a malicious payload. Originally, this was taking action. Right now, we're just surfacing it as like a UI output. But we're totally open to sort of discussing like how, like one of the other things we do is sort of kick off additional context through like scans and stuff, but we're not really taking like an upstream action other than trying to enrich context.
So hook into a nest. Just make a fire alarm go off.
Yeah,
Man, that's a good idea. That's a great idea, actually.
Star Trek, the bridge sound.
Or they will, like, the hues will flash or something. Yeah. Yes, sir.
What's it do for SSL?
We don't terminate SSL right now, so that's kind of one of the things that's tricky. And I think encrypted traffic, like when we scope a large environment, 50% of all the traffic is encrypted, and if they're not, I mean, most shops will, like, when they're dealing like with kind of multinational sort of cases, like we will run into like compliance issues when we try to terminate SSL, and it becomes super tricky.
We may use Flow for it.
Yeah.
Mm-hmm. Yes, sir. Here you go.
Okay. Is the goal to make this more of a framework or more of a tool? I.e., is this more going to be so that the analytics side currently using Bro, Nmap, and POF to be able to whatever particular implementation you're using in your network, tie it into this, and then it handles the machine learning side of it? Or is it designed more to be as a machine learning in and of itself?
Yeah, it's meant to sort of be like kind of standalone in the sense that as long as you spin the ISO up, like, and kind of like either just taking like a tap or sitting in line, basically it's gonna generate all the data based off that tap, and so you're going to you're really going to kind of get all of the machine learning and all this stuff for free once you sort of deployed it in the right way. But that's why, so we kind of had to make hard choices on some of the initial like tools that are giving us the log data.
But it's going to be its own ingestion point,
Yeah.
rather than being able to plug in your own.
Yeah,
Right.
exactly.
Right.
So what would be missing if I, instead of doing this in my home network, I threw this into an ICS environment?
Well, I think one of the things we were thinking about a lot was just the IoTs, like
It's generic.
yeah, like
Right.
would there be? But would you
New
have?
ports, traffic flows, abnormalities. Like I just don't see anything here that tells me, other than attack patterns. I don't see anything here that doesn't say, well, I should just have this go monitor my ICS environment.
Well, I guess one question I'd have is like, because we're sort of. I mean, it always kind of comes down to the ETL parsing effort, and we haven't scoped like kind of some of those esoteric protocols like HVAC or like, would that be in scope for what you're thinking about?
It could be, but here's the thing: all that traffic, I don't think you have to understand the protocol so much. Right?
Yeah.
All you got to know is that
Yeah.
this thing sends 20 packets here every 20 seconds.
Exactly.
The second you deviate from that,
That
Right.
and that, as long as that the hypothesis is that we just need to make super simple baselines like that, and the population isn't too big, then we're good to go.
Right.
and yeah, right. Typically, your population is pretty fixed.
Yeah.
Like
Stuff
in this environment is not designed to change a lot.
Right.
Yeah, and it's all usually just legacy.
Right. That's a great point. The thing about it is, in the case of ICS, we'll have to look at how the data will be coming, because I can tell you that when we were at UVA, we had ETL NIMers. ETL also almost became like a challenge.
It is doing ETL on data that you get from disparate places, and especially like the crap that comes off of these PLCs and stuff. Forget it.
Yeah.
Right.
That's a good question. I think that's we can just sort of avoid.
We'll take a look at it, but yeah, that's a great point. Thank you. Yes, sir.
Are you targeting, is it basically the same as security onion is at this point, or are you targeting?
We want to make it as usable as Security Onion. You just spin the ISO. You're gonna have to spin it on some sort of a hypervisor, and then use it from there. That is a great point. We've been looking at the Raspberry Pi 3. We don't think it's going to run in it because of the ELK, but maybe in the future we'll be able to integrate it. Yes, that's a great, yeah.
Sort of a little big of a dependency last minute with ELK and Kibana, kind of just to find a way to visualize stuff, and it kind of made us, because Rod was sort of, one of the requirements when we originally started was to just have this integrated in the security onion, but the Kibana thing kind of...
Yeah, the library dependency, yeah.
I think the right thing is to get this into security onion.
That's what we eventually, where I would like to see is a compacted binary that you just download and run, and that's it.
There's a beta version security onion that uses ELK now.
Oh, okay. We'll take a look at it. Yeah, definitely.
Okay, cool. When you talk about requirements from 5 to 10 users, I mean, how do you classify user? I mean, well, I see 5 to 10 users, I see 40 devices on it.
Yeah.
Right. Well, there is that. I guess we addressed that with the dynamic discovery. There had to be some sort of a normalization.
Identity resolution.
Right.
Ideally, we will kind of take like Max as first-class citizens. That's not really like working as planned. So it's kind of I think if we... I was trying to think where we're seeing the usernames in the Bro module.